Alrighty then, so let's get going. So, hi everyone, I'm Chris Saxon, part of Stephen Feuerstein's Oracle Developer Advocate team, and it's our job to help you get the best out of Oracle database and hopefully have some fun while doing so. So with that in mind, we're going to be looking at some of the cool stuff which is here in PL SQL in 20C to help you build better, faster applications. So let's go over and look and see what's going on. If you've got any questions as we go along, please put them in the chat and we'll address them as best we can. Or sorry, I should say put them in the Q&A window. There's chat windows and Q&A windows. If you please put them in the QA windows, that'd be better. It makes it easier for us to manage what's going on. Alrighty then, so let's get started. And let's start by talking about a common problem for businesses as they start to expand around the globe, and that is dealing with currency conversions. As your business grows, you'll start having to deal with international payments. So this means several things. You might need to display prices in different currencies on your website. You might need to accept payments from different countries and currencies, and things like invoice generation, other background batch jobs may need currency conversion. So in order to do that, you may need to do something like this. You need a table storing from and to currency codes and the exchange rate from them. So it's pretty straightforward, fairly simple table, but this query could be executed really heavily. You know, if this is something that's on your website displaying your prices, pretty much every page load, or certainly every product page load, you might need to do this currency conversion, really heavily executed. Or if you've got a batch process dealing with your invoice generation and so on, you might need to run this process, this type of query a lot during that process as you reconcile everything. So it runs a lot, but for a lot of businesses, you'll just work with daily exchange rates. So the values here don't actually change that often. They only change once a day. So we've got a query, we run it a lot, and the data changes very frequently. Kind of prime candidate for caching it, right? We want to be able to cache the exchange rates, so we don't have to run that query quite so often. Now, at this point, people go, caching, we can look at things like Redis or some other, memcache, some in-memory database to do that. And it's true, you can, but generally, you don't really need to go to that extreme. We can get a lot of benefit from just caching things in a PL SQL table. So we can load those exchange rates up into a table indexed by the currency. So we can get the indexed by the currency, get the exchange rate. And we can load it up with a query a bit like this. So we're looping through the exchange rates. Once a day, we load this up, or at the start of the batch process, and we can get the current exchange rates. Pretty straightforward, and then we can access particular exchange rates just by indexing by varchar2. So we've made the currency we're converting to the index for this collection, and we can just multiply it. Pretty straightforward. But things are a bit more tricky if we want to get all the exchange rates. So it's nice if we get one specific exchange rate, but what if we want to get all the exchange rates, show what's all that's currently available? So we need to walk through the entire array. It's where things get a little bit fiddly when it comes to PL SQL. We've got an index by varchar2 table, so you've got to do something like this. We need to do a while loop to loop through all the code, to pull out the variables and see what they all are. Bit of a faff. It's a lot of code to write just to kind of get the values out of it. And because it's a while loop and you've got the termination conditions, very good chance of making a mistake and just accidentally coding an infinite loop while doing this. I've done that many, many times.
As have I.
Yeah, exactly. I think we all have, haven't we, Stephen? Made these into infinite loops because we haven't got the termination conditions right, or we forgot to get the next element each time around. So it's a bit of a fiddle, and a bit of a faff. So we've got kind of two problems here: loading the values into the array, and then once we've got them, looping through them and getting them out again. And in general, looping through arrays, if it's not a densely packed number array, if it's sparsely populated varchar2, it's actually pretty fiddly, or it can be. You have to write lots of code like this. So 20C, we've addressed this with extended iterators. And the really cool, really nice thing you'll now be able to do is actually use things like the index of the array to walk through to define the iterators. So instead of having to do our while loop, we can just say indices of the PL SQL array. So this is a really big, really powerful feature with a lot to it. So rather than kind of walk through a whole bunch of slides and probably bore you all to death, what I'm going to do is at this point jump over to a demo showing you how this all works. So here we go. I've got SQL Developer up. What I'll do is I'll kind of build it up gradually, walk through some basic examples. So to start off with, I'm going to load up a table, just giving a SQL number table with all the even numbers between 1 and 10, so 2, 4, 6, 8, so on. And that will be the index and the value of the array. So we can do something like that. And then in the past, if we wanted to iterate through those, we'd have to do some lovely while looping thing like this. And come on, if you execute, if it, oh, what's it doing? Come on. Connection, come on, work. Have I lost my, okay, hang on, give me a second while I just restore my connection. Any questions at this point while I just get that up and running again? So hopefully now, there we go.
So that was a sweet little piece of syntax sugar there, just to be able to say in indices of, which formerly was a part of the for all statement. So they extended the same syntax now into the for loop.
Yes, so thanks, Stephen. Okay, so we're back at last. I've got restored my connection. So you can see we have to write quite a lot of code here, and we got the values 2, 4, 6, 8, 10. That's pretty straightforward. But as I said, it was a lot of code to do that. So now there's a few things we can do. So first up, rather than having to do this mod here to say all the even values, we can change the stepping. So previously, we've got for loop, it increments by 1 every single time. What we can do now is have this little by clause, which says increment by 2 every time we loop through. So this will give us 2, 4, 6, 8, 10. And as we saw with the indices, because this is sparsely populated, instead of getting lovely no data found exceptions, we can loop through it and get the values 2, 4, 6, 8, 10. Way! So much less code. So hopefully, we compare the two of these, we can see it's pretty straightforward or much easier. But there's a lot more power to this and a lot of other cool things we can do here as well. So we've walked through the indices of the array. So very useful for sparsely populated arrays. What I'm going to do now, load up an array with index 1 to 5 and put the values 2, 4, 6, 8, 10. There is also, as well as the indices of and values of, which if you've used the for all expressions, you're probably familiar with to some degree, there's this new pairs of syntax as well. So what this is doing is saying, use the index of this array and then the values for that array and loop through those. So we're separating the index and its values itself. So here the indices are 1 to 5, values are 2, 4, 6, 8, 10. And if we run that, you'll see that we get index 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. So if we look at how I specified the values here, instead of in the past, I'd have had to pass the array and the index that we're trying to pull the value out for, I can just straightforwardly specify the value. That's the index of this an array, because that's the pair. It becomes much more useful later on if we've got complex types. If we've got arrays of records or cursor row types and things like that. So it becomes much easier to access these particular values. So we can do indices, pairs, there's also values of as well, which is similar to the for all syntax we've had before. So move on and look at some of the other cool things we have to do. We'll say this is a big feature. I'm just going to snapshot some of the more interesting things, give you a flavor for it. So in the past, as I said, you'd always index by 1. Now, what we can now do, you can specify an increment other than 1. You can also specify fractional increments. Now, I just remove that data type declaration. Implicitly, all these index variables are integers, so we can't have these fractional values. We can now specify a data type for the index as well. So I'm saying it is a number, and therefore we can get the values 0, 0.2, 0.4, and so forth out of the array. Being able to specify this data type, again, we'll see again later, this can be quite powerful and useful. But this increment, this stepped value that we increase each time must be a constant. Let's say rather than the even values, we want to get the powers of 2. So we want to loop through all the powers of 2 from 1 up to 100. So 2, 4, 8, 16, so on. If we try and make this an expression, we're going to get a lovely exception. It'll tell us we're not allowed to do this. So how would we go about this? Well, there's a couple of approaches we can now take with these extended iterators. First thing we can do is this repeat while. And what this means, we're starting with this value, start with the 1 on each iteration round, compute this expression, so double the value from the previous time, and what's our termination condition while the value is less than 100. So if we run that, we should see, hopefully, yep, there we go, 1, 2, 4, 8, 16, 32. So we've done all the doubling values. So this is, if you're familiar with Java and C syntax, where you've got like I equals 1, I is less than 100, I plus plus. It's kind of similar. It's slightly rearranged in a different way, but it's a similar concept where we're saying, keep running this thing, whatever this expression is, until we hit this termination condition. Now, we talked a minute ago about infinite loops and while conditions. Make sure, double check what your termination condition here is, because again, it's very possible, we do greater than minus 100 or something, we can get stuck in infinite loops quite easily doing things like this. So
my prediction is that a lot of us are going to be writing infinite loops for a while as we burn in this feature into our brains.
Yes, well, I've already written a few while using this feature, so I think you'll bang on with that prediction, Stephen. So we can do this repeat while. Another thing we can actually do to do these doubling is actually manipulate the index variable within the loop. So previously and always, if you try to change the value of the index within the loop, so here we're doubling it, you get an exception. It tells you you can't do it. You can't assign it a value because it was controlled by the iteration loop. Now we can declare them as mutable, so we can change its value on each loop round. So what we'll do, we'll output it, then we'll double it and subtract 1. And you can see we can get the values 1, 2, 4, 8, 16, and so on. And now again, you do have to be quite careful with this because it's possible to write your iterator in such a way that you get stuck in an infinite loop. It will keep going until I is greater than or equal, is greater than 100. In this case, if I screwed this up somehow and we didn't actually increase it, we could get stuck infinite loop forever. Eric, absolutely awesome. I'm going to be busy when this gets out. Yep, I think a lot of us are going to be quite busy when this comes out. Now, one thing you might be looking at this and going, well, I'm doubling it, so why do I have to subtract 1 as well? So even though we're assigning this value within the loop, when it starts the next iteration, it still then increments it. So there's a little subtlety to be aware of. If I just remove that, remove minus 1, you'll see that it'll start with 1, and we'll get 1, then it will double it, and it'll increment it on the next loop round to give 3. So we look, rather than 2, 4, 8, so on, we get 1, 3, 7, 15, because that's, after the second time we double it to get 6, start the next iteration loop, increment it 1 by 1 to make 7. So again, you'll need to think a bit carefully about what these expressions are if you want to do things like powers of 2 and so on. But this does allow us to do some other cool things, such as we can now have a Fibonacci sequence generator using a mutable index. So the Fibonacci series, most if not all of you are aware, is the next number is the sum of the two previous numbers. So we can just declare that as fib, the index Fibonacci is equal to the previous plus prev, as I called it, or 2 previous. And we run that, and you'll see we get 1, 2, 3, 5, 8, so on and so forth. So there we go. Nice little way to generate values for the Fibonacci sequence or other kind of sequences numeric sequences that you might want to play with. So we've seen them, like I say, I'm giving a brief overview. There's a lot of cool things in these iterators. There's one final thing I wanted to show you and take some questions for a minute, I think. You can also chain these iterators together. So far, we've just dealt with one iteration at once. Here I've got 3 separate things. I'm going to start off, reverse 1 to 3. So count down from 3 to 1. So 3, 2, 1. I will then run this doubling. Once we've got down to 1, we'll start from that point, run this expression, double it, and until we get to 16. So 1, 2, 4, 8, 16. Once we've got to the end of this iteration, we'll just go through the values 10 to 12. So we do that, and give it a second to go. There we go, 3, 2, 1, 2, 4, 6, 8, 16, and 10 through to 12. So it's pretty powerful. I've seen people on Twitter doing all sorts of crazy things with this and showing how you can chain together to do all sorts of weird and wonderful things. In the pure form like this, I'm not entirely sure why you would want to do something exactly like this. Maybe you've got some funky reason. I'm sure there are. But this will actually come in very, very useful a little bit later on when it comes to actually loading values into arrays. So at this point, I think it's a good chance we covered quite a lot of ground there. Let's see if there's any questions that people have got, or if you've got any comments, Stephen.
So nobody has logged a question yet. I think everybody's jaws are just hanging open.
Yeah, probably.
Oh my God. I mean, I love the syntax. In terms of being able to chain them together like that, it'll be interesting to see what kind of use cases people come up with, and I know you've got one coming. Yeah. Here's a question. Can you iterate over us like Jason, Stephen, John? So that would be indices of, I would say. I don't know about any of these other clauses. Go ahead.
Yeah, I was going to agree with you, Stephen. I think you can, if you've got an array which is, well, you could do indices of or values of as well. You know, indexed by it's table of varchar 2 indexed by PLC by integer. You could, instead of doing indices as I've done up the top, you can do by values. So there's a couple of a bit different approaches. Okay then.
And another one, should I use reverse or by -1? Well, I would say that that's up to you to decide. You get to pick, but I would say if the idea is that you want to go in reverse through your indices, you should use reverse because it's more declarative and it'll be simpler for people to understand. Yeah. And a question from Philippe Savasberg, who was behind these changes? Philippe, I thought it was you. Didn't you put an idea on the community ideas forum? I have not gotten an explanation from the PL/SQL team about the history behind implementing this. My impression is, besides the clear simplification of code in terms of iterating through collections, which I think we'll find to be the biggest value for us, I think in general it was a step by the PL/SQL team to say, let's bring PL/SQL up to the same level as other languages. In other words, these are the things that people have come to expect in programming languages. Why not make them available in PL/SQL as well? My guess would be that a lot of these more complex structures that Chris is showing you now, the 3 different chaining together and this, that, and the other, will probably be used relatively infrequently in our community, but it'll be used. And for sure, I'm assuming that once it's available for everybody and widely in use, you will go back and you'll get rid of those while loops first and next, and that's where I've done most of my infinite loops, by the way. Oh, I forgot to put in the next. Yeah. Next would be nice. I'm sure that's going to become the common syntax in PL/SQL.
Yeah, I think you're right there. I think if we go back to this is going to be the thing which is going to make the difference to most of you and going to be the biggest thing. And I think it's one of those where there's a lot of functionality. They've kind of built the whole feature, so there's lots of tools. Some of these, again, they're going to become a bit more clear about uses for them in a little bit. But yeah, it does look shocking and crazy. So comment from Judith, the syntax is a little bit unclear and only very similarly badly in the PL SQL doc. Yes, we know that we are working on better examples. So when this is fully available and fully released, hopefully the docs will be improved with more and better examples. I think the primary use case, indices of array, perhaps the pairs of as well, is pretty straightforward to use. But yes, we are aware that we need better examples there.
Is there any option to iterate a JSON-like varchar variable?
I'm not aware specifically. I guess if you've got did you have a comment, Stephen? Or?
Well, first, Pedro, if you have any more clarification about what you're looking to do, so you can declare your index to be of type varchar too. I don't know, can we declare it to be of type JSON? JSON's I think you're going to be talking about that a bit later in your session, but I assume, could we declare an index in a loop to be of type JSON?
There's the PL SQL JSON types, isn't there?
Yeah.
So I haven't played with that actually, to be honest,
yeah.
but it's possible. I guess if we've got a bit of time at the end, maybe we can have a fiddle and see what we can do.
Okay.
Alrighty then. Okay, so we got lots of other things to get through. So at this point, I'll go back over to the slides, and we can get going. Keep your questions coming if you want them, but I'm gonna move on because we've got other things we need to get through. All right then. So quick recap of those extended iterators. So we can now define custom increments. So you've got the by stepping to say increment by 2, by 3, that kind of thing, a constant value. If you want to increment by an expression, then you can use the repeat while to say doubling, tripling, or something like that. So you have a non-constant increment each time around. Just remember, it will still increment itself each iteration anyway, so be aware of that while you're manipulating things. You can declare index variables mutable. Sorry, this is where the increment round comes into play. So if you actually want to change the index variable within the loop, you can now do it. Now, you do be very, very careful doing this. I got myself completely stuck a number of times, coded lots of infinite loops. I think this is probably the thing that's going to catch most people out. But you can now do this should you wish to. Biggest use by far, being able to make it much, much easier to loop through arrays, indices of, for sparsely populated arrays or arrays indexed by varchar 2, fantastic. And for a lot of us, this is going to make our code a lot easier. And we can chain those iterators together, which, as I said, a bit head scratching at first, but there is a good reason why you might want to do this. Okay, so what we've seen about looping through the array, how about actually populating the values into the array? So I did that cursor for loop, and each time around specifying the value for it. How can we simplify that? Or what can we do to simplify that? So in the past, you would have to do a cursor for loop or do something like this, have separate statements for each currency, setting the value each individual time. 18C, we simplified this a little bit with qualified expressions. Each type is its own constructor, implicit constructor for it, so we can do this all in one pass. Again, this is a bit fiddly. We're probably pulling these values out of a table somewhere, so it's not always practical to do something like this. So next big thing I'm going to talk about, aggregate qualified expressions, or perhaps better understood as array type constructors. So what we can do is initialize the values for an array using our iterators we've just talked about. So instead of saying USD, equals whatever, we can now increment set values using a for loop. So something like this. So this will initialize this array with all the values from 1 to 10. And again, there's a lot of power here, a lot of cool things we're going to do. So I'm going to jump back to the demo. So let me jump back over here, and we go to these array constructors. So again, we'll start with what we might have done in the past. We'll just load it up, an array up with the values 1 to 10, and it'll be indexed and the values will be the same. So pretty straightforward. We'll do that, 1 through to 10. what we
I'm
can
still
do.
seeing your screen, your slides.
Oh, sorry. There we go. Forgot to resume my share. There we go. So we can see we've got just looping through, loading up the values 1 to 10, and then looping through to spit them out again to see what they actually look like. So on that, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. So 18C, we could have done something like this. The index value 1 is 1, 2 is 2, and so on and so forth. This works if you've got maybe 2 or 3 values and you know what they are and so on, but here it's a bit impractical, right? Only works for a small number of values. We can get the values 1 to 4 here. So now, 20C is we can use our iterators within the constructor. Fantastic. So when we do this, we're going to loop through the values or initialize the values 1 to 10, and it will set the index and the value for this array both to 1. We'll use the indices of as well. So you can see we get the values 1 through to 10. Pretty straightforward. So there's a lot of other cool things we can do with this. Particularly we've got all the power of the extended iterators we've just shown you. So you can chain them together. So this will give me the values 0 through to 8, and then all the numbers 16 through to 20. And if we run that, you can see we've got 2, 4, 6, 8, jump through to 16, and then through to 20. So we can chain these together. Now at this point, you're probably like, well, what's the point of this? Why would we do this? Well, what this allows you to do is combine arrays really easily. And this is where chaining iterators is probably going to be most useful, or it's the use case that's most obvious to me anyway. So we're going to load 2 arrays, one which has values 1 to 5, another which has index 11 to 15, and the doubling of those are the values. So the values are 22, 24, and so on. We can then initialize this other array to be the combination of the 2. Now notice I've used the indices from the first array and the values from the second array. So first one, index and the values are the same, 1 to 5, but this one, the index and the values are different. So if we loop through that and see what we get, we can say we get 1, 2, 3, 5, and 22, 24, 26, and so on. So I think when it comes to chaining iterators, this, at least to me, is the most obvious use case where you're going to use it. Combine 2 arrays, or it could even be 3 or 4 arrays, into one in the results, and just pull them together. So we can do that
And
by
save us so much code. That'll
exactly.
reduce our code so much.
Yes,
it's really nice.
Yeah, so I think it doesn't happen that often. It's one of those things that comes up every now and again. How do you combine 2 arrays? I remember in the past doing something like this, and it's a bit of takes a bit of thinking about, doesn't it, Stephen? So
for sure. Yep. And this will take some thinking too, of course, to get used to the new syntax and how it all works together, but very flexible.
Yes. So what we can do, so in this example, we've loaded up and the index and the value are exactly the same. In this, we've used an expression to define the value, so they're subtly different. You can also specify the index, a custom index, which could be an expression. So this time, the values are going to be 1 to 5, but the indices are going to be 2, 4, 6, 8, 10. So we load that up. We see now we've got the indices of the even numbers. So we can specify a custom expression for the index here. And if we go back to combining arrays, we can use that pairs of syntax, which might be quite useful here. So we're saying for the indices of arrays 1 and 2, and then get the values for each of those. So the index is going to be the indices of each one, and the actual values are going to be whatever stored in them. So I'm going to get 1 to 5 and 10 to 15 as the indices, and then 1 to 5 and 20 through to 30, or the even 20 through to 30 as the values. So you can see we can split those up there. So this potentially is quite useful in some scenarios to help you with that. Now, another thing we might do, getting a bit more complicated. I've got a record here, which is just a number and a character, but we've got a table of those, 3 things which are table of those. So our first is A, 1A, 2B, and then 3C and 4D. we can combine those using pairs of like that and loop through them to get them out as well. So the indices are values 1 to 4, and the actual values are, 1A, 2B, and so on and so forth. And it's much easier to specify them. So if we look, when it comes to using this pairs of, this is where it probably becomes a lot more useful, is when we've got these complex types, an array of complex types of some description. Instead of having to actually do this, we can just specify the value. So these two lines here mean exactly the same thing. This, because we've used pairs, is just slightly simpler and a bit more straightforward to do.
Chris, question.
Yes.
So in pairs of, can you explain the use of the word pairs? Like, how does that mean something here? What's the pairing?
So the pairing is the index and the value. So for each element of your array, you've got whatever the index is and the value within it. So we're saying we've got two things here. That's what our pair is, essentially. The index is the first part of the pair. So it'll pull out whatever the indices are here, 1, 2, 3, 4. And the values are whatever is ever at position 1, whatever's at position 2, whatever's at position 3. And I'll uncomment this to show, if we put these side by side, they do exactly the same thing. So 2B. So this value is this, essentially. So instead of having to specify your array variable and its index, you just specify the value at that index. So, is that helping?
And does pairs always correlate to the value in the collection? That's what that. So the pair means the second one is the value of the collection at that.
As far as I'm aware, I haven't seen anything that you could do to specify differently now. Well, I think, have I got an example in a bit where you can get a bit more crazy with this? As we say, we're kind of skimming the surface a bit here, but trying to give you some flavor of the things you can do. But yeah, as far as I know, these values are just whatever the whatever's at that.
Okay, thanks.
So far we've been mostly doing index by integer or number or some kind of numeric value. What we can also do, as we talked about, is index by characters. And because we've got this index syntax, we can now use that to specify the values. So your ASCII character codes, 65 is capital letter A. So we're going to load this up with A, B, C, D, and so on and so forth. Loop through those, and you can see we've now got our array A, B, C, D, E, F, G all the way through. So this potentially allows you to load up index by varchar 2 variables fairly easy as well, something that was quite tricky to do in the past. So now getting even more powerful, even if this is showing you getting things to another level, we can also use a cursor to initialize these things. And here we are looping through the cursor and specifying the index as the value from that cursor and initializing it. So this is just the values 1 to 10. We run that and we get values 1 to 10. So that's not very interesting, right? Let's come back to the problem we talked about in the beginning, our exchange rates. So we've got our table of exchange rates, and I'll stick some values in there, some various pounds to various currencies around the world. In the code I started with at the very beginning of this, I was having a for loop like this to initialize it, and then my lovely while loop to actually iterate through it. So we had our for loop. So now, instead of doing this, what I can do is declare that cursor and say, this is our index variable. I'm declaring it, this is the type of it, the cursor %row type, with the custom index of the currency we're going to, and that's the value. Again, I'm going to use the pairs off here, so we can see there's our currencies and those are the exchange rates. So, in the past, there wasn't really a good, easy way of loading values into a index by varchar 2. You have to do this cursor for loop, really, or do some other messing around. Now you can do it all with one little thing like this. Very good. Okay, so those are kind of the examples. And at this point, I'm sure people's brains are even more exploded. So let's pause for a second, see if we've got any other questions or comments coming in. Okay.
An additional question, if you look under the answered section,
Yeah.
there was a follow-up around JSON. And you can take a look at my answer. I think that there's nothing built into the extended iterative feature set for JSON specifically, but I'm thinking there must be some possibilities of either writing a function that returns the iteration values you want, or maybe an expression that can be written right into the loop itself.
Yeah, I think actually I'll pull the I see there's some code in that thing. Oh, I can't. It's not letting me copy it for some reason. Come on, let me. There we go. Copy. I can paste that in. So this is an array. This thing here, and we may be able to use the indices of. So yeah, we can pull that out. I'm hoping if we can do that. No. Okay. The indices. Hang on. I got that syntax right. Pairs of indices.
Looks okay.
Yeah, looks okay. Okay, so maybe it's not working right.
And what's the rest of the indices of iteration? Does not have a collection type.
Okay. All right.
Right. So indices of refers to collections. Right. That makes sense.
Okay. We'll have to look into this a bit further. It's probably possible in some way or another, but yeah, we'll have to look into this in a bit more detail to kind of figure that one out.
And there was also a question from Judith about using these not only for associative arrays, but nested tables and V-arrays.
Is that, let me check, well, we can.
I was about to write, well, yeah, of course you can, but then I was thinking I should go check the documentation.
Yeah. Let me.
I don't think it's restricted to associative arrays. In fact, you could just take off some of the index by clauses. And
let's find a nice simple one at the start. Where
using predefined.
Using predefined types.
Just change it to a type of integer.
Yeah.
Live demo, folks. Takes a lot of confidence.
Exactly. See if this works.
That's what we pay him for.
Oh, I need to change that as well. There we go. Hopefully. There we go. Yeah, it's worked.
Yeah.
So, yes. Yeah.
So that's not a formal proof statement, but it's a pretty good indicator that, yes, this will work with all the different types of collections. But basically, I think the way you should think about it, folks, is that if it works for indexed by varchar2, it works for everything, because in the past, they'd add new features and it would just be nested tables or V-arrays. Then we started to get support for associative arrays, for example, with the table operator, but not for indexed by varchar2s. This one supports varchar2s, and you can be pretty sure everything else. Thanks, Chris.
Yeah. Okay, cool. Any other questions, comments? I see people saying things like it's a bit like dictionary in Python or like key value pair, and I believe they have looked at how this works in other languages and used a lot of these concepts. I think actually a lot of the inspiration came from Ada, which is the predecessor for PL SQL, has since updated and included a lot of these iterators, if not all the things we've just talked about. So I think they have looked at what's available in other languages and gone, oh yeah, it'd be good if we could include these. From Liz, wow, used to get hand cramps writing this stuff, less code, less mistakes. Yes, exactly. So exactly. Hopefully this will save us all our fingers a bit more.
That's right. And we have, will there be a dynamic unpivot clause in the future without having to type out all the columns by name? There's a little change of topic.
Yeah, that's a bit of a switch there. I don't know if there will be a dynamic pivot itself. There are sort of ways, well, there's a couple of things we've introduced, polymorphic table functions, and something else I'm going to talk about in a minute, which can mimic that functionality. I don't know if the pivot or unpivot itself will support those, but there are things you can do to get close to it. Okay. Victor's excited about all these changes. He got carried away there. There's such excitement. All right then. So yeah, we need to move on. So I will go back over to my slides for a minute, and we'll get back up and running. All right then. So let's just recap on those very quickly. So we can now use our iterators to initialize arrays, and that has that full extended iterator syntax, so you can do all sorts of crazy, weird, and wonderful stuff. However, probably the thing that is most useful for you will be combining two arrays, merging two into one, or even three or four into one. I'm sure for some of you that's going to be a lifesaver. And also, we can also now use a cursor to load data into an index by varchar2 table, making things a lot easier. So a lot of this is simplification, a lot of power. There's lots of stuff I'm sure most of you will never use, but the core part, the cool part, I think will become day-to-day stuff for a lot of us very soon. So let's keep trucking on. So we now loaded our values into our array of exchange rates, and we can now nice and easily reference the exchange rate for a particular currency like this. So we can go from get the USD, get the chuffs, get the euros, whatever. Pretty straightforward. And if we're going to use this a lot within a process, can save us having to run a lot of SQL. But there's the question here is, we've got to convert these values, do the exchange rates. Which way do we do the conversion? Are we multiplying it or are we dividing it? And this is one where I always have to sit and think about it a couple of times and just check, have I got this the right way round? Are we multiplying or are we dividing? And this can be pretty tricky to spot. Currencies like euros and US dollars have a very similar value. So if you get the multiplication or the arithmetic the wrong way round, it's not immediately obvious. So you need to test thoroughly and check that you are multiplying or are dividing. So to avoid this kind of problem, well, what should we do? Well, we should create a function, create a standard function, which we should always use, and therefore we don't have to think about it and worry about whether we got it the right way round each time. We can also use this to do things like handle rounding and figure out what to do with all the decimal places and the cents and so on. So we can use this, and instead of doing the calculation directly in the code, we can just call this function. So do that to initialize PL/SQL variables, or we can use it in SQL like this: insert values, select statement, and so on. However, as soon as you start doing this, calling SQL in or PL/SQL in SQL, I should say, there's always someone who starts panicking and going, danger, danger, we've got the context switch, performance, it's all going to get really slow. What do we do about this? And this is actually a particular problem, can be a big problem. If you're calling PL/SQL in SQL, every time it invokes that function, there is the context switch between those two runtime engines. And if you're processing lots and lots of data, or you've just got really extreme performance requirements, that overhead can really slow things down. And, you're then in this kind of bit of a dilemma. Do we have nice, maintainable, reusable PL/SQL functions and accept the performance hit, or do we go pure performance, strip all the PL/SQL functions out, but now people, every single time they're doing these calculations, they've got to double check they're getting it right, and there's more risk of bugs creeping in. What do? There isn't a simple answer, and you tend to have to decide on a case-by-case basis about how best to approach it. So how can we get around this? Well, in the 12C time series, we came up with the Pragma UDF, which was, you declare a PL/SQL function, use this Pragma, say we're going to use it in SQL, and it will help make this context switch a bit lighter. It helped a bit, but it didn't completely eliminate it, and there was various controversies around it. Now, in 20C, we have another way, SQL macros. So what these do is they return a SQL fragment, so part of a SQL statement that you can then embed in your SQL code. And what you do, you create these by creating a PL/SQL function. So SQL macros come in two flavors, table and scalar. So table macros are ones that you use in the from clause of your statement, and scalar macros are ones that you can use everywhere else. Basically everywhere else it's legal to use a PL/SQL function. So select, where, order by, and so on. Table macros have been backported to 19.6. scalar macros, you will still have to wait for the next release to actually be able to use those. But I've talked a bit about table macros in the past. Today I'm going to focus a bit more on these scalar macros because we can see how to use those to write those functions. So in the past, we'd have our function like this, return number, do our calculation. To make it a macro, we're now returning a varchar2, which has the clause SQL macro, scalar, it could be scalar or table, and we're returning a string. So what happens when we call this function is the database essentially makes this part of your SQL statement. And it does that by taking whatever the text, the exact text of whatever you pass for the actual argument values, and doing a find replace of those of the string within the function. So to give you an example of how this might work, if we call convert currency xrate 10, so let's imagine xrate is the column, at pass time, when we submit the query to the database, it resolves that to xrate times 10, okay? If instead we're passing in our associative array and a bind variable, it doesn't look at what these values are. It doesn't resolve and find out what the exchange rate for USD is and what this bind variable value is. No, literally exactly what becomes in the final SQL statement is xrate USD and that bind variable value. So it takes the text of what you are passing and does a find replace of that within the function and makes that part of your SQL statement. It does not evaluate these. And this happens when it passes the SQL statement. So at this point, again, I'm going to jump back over to a demo to show you how.
Just to drive that point home a little bit, Chris, when you say it's done at parse time, that means there is no context switch at runtime to the PL SQL engine.
Exactly.
We're done with the PL SQL side.
Exactly. So I've got a little demo which will hopefully make this even clearer. So we can see we've got our convert currency macro, and notice I'm returning a string here. I've quoted this. So if I create that and call it, essentially what the database is doing is resolving this into that. So you can see I've passed the column xrate in times 10. So these two things are actually equivalent, because when the database parses, optimizes this SQL statement, produces its execution plan, it essentially removes this function out of the thing. So there is no context switch. It's gone. It's no longer invoked every time we run the SQL statement. Side effect of that is, because this is returning a string, we can now no longer call these in PL SQL. Okay, so give with one hand, take with the other, right? We can't have this single function which we're going to use everywhere in our code. You've got to make that potentially still a decision. Do we want a reusable SQL macro we're going to use in SQL statements a lot, or are we primarily using this function in PL SQL, which is the dominant use case? Or do we have to do both, right? Okay.
And just to be clear about that, you can call the SQL macro inside a SQL statement inside PL SQL.
Exactly.
Just not natively call it in PL SQL. Okay.
Exactly. So I could do, begin, select into, and so on and so forth, but we can't just do a direct assignment to the function like that. So just kind of talk a bit more about that context switch and the effect of that. So you can see I've got pure PL SQL version, which you've probably got in your code today, a UDF version, which uses the Pragma UDF we introduced as well, which is supposed to make this a little bit faster, we call it from PL SQL. And I've got a little routine here, which is going to loop through these. So you can see I'm calling these in some dynamic SQL, protecting from SQL injection here. I'm going to run this a number of times. So I'll just let that run for a minute and see if we've got any other questions or comments coming in while that chunks away and shows us which hopefully is the fastest. Alrighty then, so if we look at, so using the PL SQL, making a SQL macro, so it's taking, what is that, 2800ths of a second on average to do 500 loop iterations fetching 1,000 rows. That's pretty quick. We can see the pure PL SQL function takes quite a bit longer, 5 or 6 times longer. And the UDF function, primary UDF, is somewhere between the two, maybe about 1.5 times using this macro. So the key thing is with this macro, that context switch is eliminated. It is gone. So once the database has got the execution plan for it, it's fast. We don't need to worry about that anymore. Would you only use this to prevent context switches, or does it have extra functionality compared to using a normal function? So that's a really good question. When it comes to scalar functions like this, the primary value is removing that context switch. Table macros, there are a lot of other cool things you can do with them. Namely, you can emulate parameterized view functionality using them. Don't really have time to go into the details of that today, Marcel, but there's a lot of cool things you can do with table macros. With scalar macros, it's primarily about removing the context switch, yes. Okay. So there's one other thing. If you've still got questions, that's fine. There's one other thing I wanted to cover off quickly before we wrap up. So we'll do that, and then maybe we'll still have some time for questions at the end. So SQL macros, scalar SQL macros. So the key thing here is it returns the SQL fragment, part of a SQL statement. And when you call it, first time the database passes it, does a find replace the actual values you passed and makes them part of your SQL statement. This eliminates the context switch from SQL to the PL SQL engines. So we can have reusable functions that we've tested and made sure work in a standard way, but actually then don't have to worry about the performance overhead of the context switch. The key thing here is you must use it in a SQL statement. Now you can use it, call a SQL macro in a SQL statement inside PL SQL, that's fine, but you can't just use it standalone in pure PL SQL. So one other thing I wanted to cover off very quickly, and a small thing before we finish up. So see here, being very, very naughty. As part of our dealing with these exchange rates, if we are dividing, there's a good chance that we run into zero divide problems, or there's a risk of zero divide problems. So I'm handling that exception and say, being very, very naughty, having a when others null. It's like Tom Kite said, this is evil, you just never do it. So we have this PLS 6009 error, which warns you about that. Says you've got a when others exception where you haven't re-raised, you haven't done a raise or raise application error. So you can warning you that you should not do this, basically. Bad idea. So that's right and correct when we've got when others null. But what if we got when others log error and we actually raise an application error within this procedure? That's interesting. We are still going to get that warning. So this isn't good if you're one of those people who really strives to have no warnings in your compiled PL SQL. There is a way around this now. This is a new Pragma, yet another new Pragma, suppress 6009. And I will jump to a very, oh, hang on, I wasn't showing that, was I? Nobody told me. So you can see we've got the zero, we've got the when others null. 6009, that gives us an error. We're logging an error. And there's an exception handler in there. We can now suppress that with 6009. So let me jump back over here and final demo very quickly. Last few minutes we've got. So I'll enable all the warnings. So I've got my procedure here, and I've got when others null. And you'll go, no, you've been very naughty. You've got a when others with a does not end in a raise. Sort it out. So that's fine. That's all well and good. Let me just get rid of that compiler thing. I've got my logging procedure. I've got my standard logging procedure. Do some logging stuff in there, and at the end of it, I raise an application error, and maybe I'll have the ID of the log message and so on, or the entry in the log table. So we'll compile that, and I will now call that in the when others exception. So we do that. I still got that. Oh dear, you've got that doesn't end in a raise. But if I actually execute it, well, we still do actually raise the exception. It just happens within this procedure here. And the PL SQL compiler doesn't resolve that, or doesn't look into this to kind of go, actually, yes, you really are raising an exception there. So how can we get around this? Well, this is where this new Pragma comes in. So the first question is, how do we actually use this? So we've got Pragma, you suppress, and you put in the name of the program unit that you are suppressing the warning for. Now, the way you might think about, and the way I first thought you might use this, we've got our procedure P with our when others handler. So I'll suppress the warning there, right? Because we've got my procedure there. But we'll do that, and oh, I've done some wrong. Haven't used it right here. I've got not only 6009, I've got another new warning as well. It's misplaced. So it doesn't go in the procedural function with the when others handler. It goes within this program unit, which actually does the handling of the error. I need to change that to be log error. So first glance, it seems a little bit counterintuitive, but when you think about it, probably you've got this log error procedure throughout your code. It's much better to just add this Pragma here in one place in this log error, rather than go through all your code, which has this exception block, and say, oh, we need to stick the Pragma in this to avoid the warning. So here we only need to do it in one place. So I do that, and that compiles that. And now if I recompile this, we've got no warnings. So nice, solved any problems we've got where things are giving us warnings about, you haven't followed coding principles, coding practices that you should have done. All right then, so a nice little thing to finish up. Any last questions or comments before we finish up? So, question from Judith about bind variable values to SQL macro. If I execute it past time, does that mean subsequent change of that bind variable value will not have any effect? No, you are passing the bind variable itself, Judith, to the SQL macro. You're not passing the value of the bind variable, you are passing the name of the bind variable. So what becomes part of your SQL statement is the bind variable, okay? We don't look at what that value is at pass time, we pass the name of the variable. So each time you execute it and rebind it, you'll get the new value. Sorry, you had something to say, Stephen?
Yeah, and maybe just important to emphasize that it's literally doing text substitution. That's what the SQL macro is doing, right? It's not evaluating values, it's literally taking the text and sticking it in your SQL statement before it's parsed.
Exactly. So if it's a function, it doesn't go, what does this function return? Put that in your SQL statement. No, it takes the function name and makes that part of the SQL statement. It is exact find replace. Okay. Any last questions or comments before we wrap up?
There was a little question in the chat. Should I be seeing some slides?
Yeah, that was my fault. I forgot to resume. I didn't switch my shares over properly. So yeah, sorry about that, Martin. Alrighty then.
I think that's it.
Yeah, that's pretty much. So just a couple of bit of odds and ends where you might want to go to. You want to check out the new features guide, where you can go into a bit more depth of all these features and see all those cool and crazy things you can do with iterators, aggregate qualified expressions as we call them. If you want to play with this, you can do so on our cloud with the 20C preview. This isn't part of the free offerings, so you will need to have a paid account to actually do that, or have some free credits or something like that. But it is available. Yeah. If you've got a free trial with some credits, then you can still use those to play with this. So it is available for you to fiddle around and have a little poke with, but it's not part of our always free forever or ATP stuff that we've got at the moment.
And later in this year, so can't really speak to any specific dates, but you will see a major update to the documentation and I imagine the software as well. So get started now, and you'll be doing even better when the GA version becomes available. We've had a couple of questions about slides and links. So the slides you'll attach to the office hours session. Any thoughts about what are your plans with the code?
That's a good question. I'm not sure at the moment. The ideal would be to put it on Live SQL, but that's still on 19C. I will see about, I'll have a think about where I can best make that available to you. Obviously, a lot of you are not going to actually be able to run these examples at the moment. So in the meantime, if you just want to contact me, I'm happy to share them with you directly. But yes, as soon as Live SQL gets to the next release, I will put them examples there.
All right, great. Any other questions also, not just about these new features, but we already had one question about pivot and unpivot. Any questions about PL SQL and SQL more generally before we sign off? And seeing as it's top of the hour, I think the answer is no. We're going to get back to our lives at home. So thank you, Chris. That was really excellent. And I think we've got a lot to look forward to in terms of extending the usability of PL SQL language to make it easier and easier to work with and build powerful, simple code. Please stay safe, everybody out there. Follow the rules that your government, but more importantly, your scientists and doctors tell you to follow. And we'll hopefully see you next month for more fun regarding using PL SQL to build APIs to our cloud services from one of our product managers. So take care, everybody. Thanks for joining us.
Yes, cheerio.